Assalamu alaikum everyone. क्या हाल है? वालेकुम सलाम. Which AS topics I'm covering before exams? What exam are you talking about? October, November. So if you're talking about October, November exams, then inshallah I'll be doing a stream on coordinate geometry, and I will also do a stream on equation of circles. Yes. No, this video is not for O-level students. Please watch this if you are an IGCSE student, because this concept, trigonometric graphs and equations, is not in O levels. It's only in IGCSE 0580, not in 4024. So next stream inshallah will be of AS level. Okay, so don't worry. All right, so let's start, shall we? Partial fractions and advanced binomial theorem, I think that's P3. Let's see if I can do that. Definitely not before October, November, but after that. For May, June students, yes, that is a possibility. Okay, so let's start. So as you know, we are doing trigonometric graphs and equations. So there are two parts to this. One is the graphs part, okay, where we learn how to make graphs, and the other is the equations part. Okay, now it's fairly easy, and please note that this topic was added in 2020. Okay, 2020 onwards. So if you're solving past paper questions, you will only find questions of this from 2020 and onwards. Okay, 2020 was when there was a major change, not a major change, but when there was a change in IGCSE syllabus. So yeah, and again, please note that this is IGCSE only. That is if your syllabus code is 0580. And mostly you will find questions of this in paper 4. Okay, paper 4 mostly. Not in paper 2, but paper 4 mostly. Okay. All right, so the three trigonometric functions that we will be dealing with are y equals to sine x, okay, y equals to cos x, and y equals to tan x. Now, if you have AdMaths, if you've done this in AdMaths, then this should be like a breeze for you. But if you haven't, then even then it's not that difficult. The video quality is poor. Is that the case? Shouldn't be. Thank you, teacher. I will be okay. Good to hear that. I just need a system suggestion. Is AdMath and AS level are the same? Okay, for the most part, yes. If you do AdMaths, then you get a major edge in AS level, but they're not exactly the same. Some topics are, although on paper, the same, but difficulty level is much higher, like binomial, APGP, circular measure, coordinate geometry. Coordinate geometry has one part which you don't do in A level, so which you don't do in AdMaths, and that's equation of circles. Okay. All right. So first thing we're going to do is we're going to learn how to sketch the graphs. Okay. So we'll start with y is equals to sine x. Now you will notice that you were always given a certain range, okay, that is from where you start taking your x values until when do you take your x values. So if let's say the range of x is from 0 to 360, that doesn't mean that we will take all the values from 0, 1 and all integer values from 0 to 360 like 0, 1, 2, 3, 4, 5. Obviously that would be impossible to accommodate. So instead what we do is we keep a gap in between the values that we take, okay, which we call the step. Okay, so the step that we will take is basically the interval after which we plug in our values. Okay, so we'll start from 0, and the next value that we're going to plug in will be 90, and the value after that would be 180, and the value after that would be 270, and the value after that would be 360. You can see that the step or the interval is of 90 degrees. Okay, and make sure a couple of things that you need to do is to make sure that you reset your calculator. Okay, before you start plugging in your values, if you have a calculator like the one, in fact, irrespective of the calculator that you have, just make sure that you reset it. If you plug in 0, you'll get 0. If you plug in 90, you'll get 1. If you plug in 180, you get 0. If you plug in 270, you get -1. And if you plug in 360, you get 0 again. Okay? Okay, now, so next thing you do is, now usually the x and y axis will be drawn for you, so you don't have to worry about drawing it yourself. Okay, and in fact, chances are that it will also be labeled. Okay, the values, the x, y values and the y values will also be labeled. But let's say they're not, so we'll do it ourselves. So here's 0, 90, 180, 270, and finally 360. Okay, so here's 1, and here's -1. Okay, so at 0 we have 0, at 90 we have 1, at 180 we have 0, and at 270 we have -1, and at 360 we have 0 again. Okay, so what are we going to do? We're going to make a nice and smooth curve. And this is what the curve of sine x will look like. Okay. Walaikum salam. Okay, now more about this later. First, let's go over the basic shapes of the three curves that we have in our syllabus: sine x, cos x, and tan x. Okay. Then we will talk about the rest of the stuff. Okay. So let's say that you have, and we'll complete this topic inshallah in today's live stream, topic as well as past paper questions, because there's not much to cover over here. And do let me know, IGCSE students, what topic you guys would like me to stream next. So let's say you have y is equals to cos x, and x is from 0 to 360. Okay, so we'll do the exact same thing. We'll take the exact same interval of values and exact same range of values as well. Okay, but you'll notice that when you plug them in, you get slightly different values. Okay, so when you plug in 0, you will notice that you get 1. When you plug in 90, you'll notice you get 0. When you plug in 180, you'll notice that you get -1. When you plug in 270, you'll notice that you get 0. And when you plug in 360, you will notice that you get 1. Okay, now this part is to be done with your calculator. I don't have these values memorized. Actually, I do have them memorized, to be honest, but that's because I've solved these questions I don't know how many times. Okay, and if you practice enough, then you will also have these values memorized. But don't take any risk. Just plug it in your calculator and then figure out what the y value is. Okay, so here's 1, here's -1. So at 0 it's 1, at 90 it's 0, at 180 it's -1, at 270 it's 0 again, and at 360 we're back to 1. So this is what the graph looks like. Okay, let me change the color to red, and there you go. So remember, the objective right now is to just go over the basic shapes. Mensuration, okay. Mensuration, yes, thought so. And vectors. Okay, all right. Yeah, my main focus right now is for students who are giving exams in October, November. May, June students have a lot of time. Okay, then next is y is equals to tan x. Now, tan x graphs are interesting. Mensuration in paper 1. Okay, okay. We can do that. Paper 1, you mean, okay, you're an O-level student, I guess. Now, for tan x, things are slightly different. For tan x, the step that we take is not 90 degrees. In fact, it is it's 45 degrees, okay? So this is what we're going to do. We're going to start from 0 and we're going to go all the way to 360. But the interval between two consecutive values will be 90 degrees. Oh, it will be 45 degrees. Sorry, I think I said 90 degrees. I meant 45 degrees. Okay, let's see if this is enough. So we'll start from 0, then 45, then 90, then 135, then 180. Then you will have 225. then 270, then 315, and then finally 360. Okay, now. So if you plug in 0, you'll get 0. If you plug in 45, you'll get 1. Now, if you plug in 90, here's something interesting that happens. You get something called a math error, which we'll call infinity for now. Okay. If you plug in 135, you get -1. If you plug in 180, you get 0. If you plug in 225, you get 1 again. If you plug in 270, you get infinity. 315 -1, 360, 0 all over again. Okay. And that is why, and the reason why that is because the graph of tan goes towards infinity when x is 90. Okay. So here's 45. Here's 90. Here's 135. Here's 180. Here's 225. 270. 315. And 360. Okay. So at 45, it's 1. And what happens at 90 degrees? At 90 degrees, the graph goes towards infinity. Okay, so we have a special name for what happens at 90 and 270 with the lines that we draw. And it might seem funny to you, but they're called asymptotes. So these infinite dotted lines are basically referred to as asymptotes. Now, you don't need to know what their name is, but asymptotes are basically infinite dotted lines. So if somebody asks you what are asymptotes, you say they are infinite dotted lines that a curve only approaches, but it never cuts it. Okay. What does tan x stand for? Okay. Tan x is tangent. Okay. Tan is for tangent. So these are trigonometric functions: sine, cosine, and tangent. Okay. Yes, x is the angle. And how do you find the minimum value and the maximum value? By looking at the graph. That's it. So if, let's say, we look at sine x, the maximum value is equal to 1 and the minimum value is equal to -1. Okay. How do you find x, y values? Okay, so x values we assume and y values we just plug in. We find by simply plugging in the values of x that we assumed. So in tan, the step that we take is 45. And what step? Just so you know, I'll write it down. Step is basically the interval after which values of x are plugged in. Or you can say the difference between the two consecutive values of x. Okay. Which is 45 for tan and 90 for sine and cos. So for cos also, the step is 90. Now, these are some standard rules. You don't have to worry about figuring this out yourself. This is stuff that you have to remember, sadly. Okay. Now, what's interesting to note with the graph of tan is this, that when you plug in 90, the instant you plug in 90, it becomes infinity. It gives you a math error. But if you plug in 89, tan 89, so let's do this with me. Evaluate tan 89, you will notice that you get an answer. If you evaluate tan of 89.9, you will notice that you still get an answer. If you evaluate tan of 89.99, you still get an answer. But the second you try and figure out tan 90, what happens is that you get a math error. Okay. What that means is, that the graph gets closer and closer to 90, but it never really becomes equal to 90. It keeps on getting closer and closer to it, but the closer you get to 90, the more the y value gets. Okay. So for example, if you use your calculator and you do tan 89, you will notice that you get a significantly large value. Let me write that down. Tan 89 is 57.28 something. And if you do tan 89.99, you get again a very huge value, 5729.57. Okay. But the thing is, the second you make it 90, it gives you a math error. And just like that, if you do tan of 90.01, you still get a very large value, but it's a negative value. If you do tan 90.01, you get a very large value, but it's a negative value. What does that mean? So this gives you -5729.57. That means that the graph after 90 starts from a very negative value, and at 135 it's equal to -1. You can see that from the table, and at 180 it's equal to 0. So that means after 90, this is what the shape of the graph is like. And from this point onwards, it's the exact continuation of it. At 225 it's equal to 1, at 350, at 270 it's infinity, and then at 315 it's -1, at 360 it's equal to 0. Okay, that is why we say that the one cycle ends at 180 degrees. Okay, that's why we say that. Okay, now then you have some variations in these graphs. Okay, so here is what I've done so far. This was number 3. Yeah. Then you have some variations in these graphs. Okay, and by the way, I have shared a folder in the description in which you will find my notes once we're done with the stream, and you will also find past paper questions. Okay, unsolved and solved once we're done with the stream. Okay, now, so the variations that I'm talking about, you will have something like this. Let's say you're given part A, y is equals to 2 sine x. Okay, now, the best way to solve questions like these is by making a table and one by one plugging in the values of x and writing down the corresponding y value. So I'd like you guys to do this with me. And let's say the range that's given is from 0 to 360. Okay. So tell me what happens when you plug in 0. Tell me what happens when you plug in 90. Tell me what happens when you plug in 180, 270. And then finally, tell me what happens when you plug in 360. Okay. What are the values that you see? So for sine and cos, I think I already answered that. You should use 90 degrees. Okay, now, so at 0, you will notice that you get 0. At 90, you will notice that you get 2. At 180, you will notice that you get 0 again. At 270, you will notice that you get -2. And at 360, you'll notice that you get 0 all over again. Okay, so what does the graph look like? This is what it looks like. Okay, so 0, 0. At 90, it's 2, so it's going to be right here. At 180, it's 0. At 270, it's -2, so it's going to be right here. And at 360, it's 0 again. Okay, so let's put these points together and make a nice and smooth curve. Now remember, this should be a curve. Okay, it should not look like a bunch of straight lines or 3-4 straight lines joined together. It should be a nice and smooth curve. Okay, so that was part A. Now let's do part B. Now in part B, let's say you have cos of x -1, and you're given the range from 0 to 360. Now if you think about it, if you try and anticipate, like for example, if you try and anticipate this and compare it with the actual y equals to sine x, so what's happened is that all the values have been multiplied by 2. Okay, that is why you see that your graph has become slightly taller. It hasn't become narrower, it's only become slightly taller. Why? Because all the values have been multiplied by 2. Here you have cos x -1, which means in all the values you will subtract 1, which means our graph will shift 1 unit downwards. And let's see what that looks like. Again, we're going to do that with the help of a table only. Don't try and do it directly, not at all recommended. Just do it with the help of a table. So if you plug in 0, you will get 0. If you plug in 90, you will get -1. At 180, you will get -2. At 270, -1. And at 360, 0 again. Okay, you can use your calculator to figure this out. Don't try and do it directly. No, we don't use SOCA2 over here. Okay, we're just plugging in these values. We're plugging in values one by one. So if you're asked to plug in 0, this is what you will do. Cos of 0 -1. Then if you want to plug in 90, you will do cos of 90 inside the bracket -1. Okay, 0, 25. No, I think you probably are making a calculation error or something. Just first of all, make sure that you reset your calculator. Okay. And then plug in these values again. Probably making a sign error or something. All right, now that we have the values figured out, let's mark them and let's draw the graph. So here is 90, here is 180, 270, 360. At 0 it's 0, at 90 it's -1, at 180 it's -2, at 270 it's -1, and at 360 it's 0 again. Okay, so we put this all together and we make a nice and smooth quadratic, oh sorry, not quadratic curve, trigonometric curve, and there you go. That's it, that's your answer. No, radians, you don't have radians in IGCSE or in O-level for that matter. Okay, now. So as far as graphs are concerned, these are the kind of questions that you will come across. Now let's do some past paper questions at the same time before we move on. Okay. Now remember, you will have graphs and you will have equations as well. Okay. So this was the very first question that we had of trigonometric equations, and this is from May, June 2020, the first year when this was added. And it's paper 4, variant 1. So it says here, on the axis, sketch the graph of y is equals to sine x for 0 to 360. Now, when you're doing it for the first time, like I said, you will not know exactly where to mark the values. So my suggestion is that, you will not remember the values. So my suggestion is that you always make a table. Okay? And this question is particularly nice and easy in the sense that you know exactly what values you have to plug in, and everything has been basically done for you. Okay? So here's x and here's y. Plug in 0, plug in 90, plug in 180, plug in 270, and then lastly plug in 360 and see what happens. Now I'll do this for you guys. If you plug in 0, you will get 0. If you plug in 90, you will get 1. If you plug in 180, you get 0 again. If you plug in 270, you get -1. And at 360, you get 0 as well. So at 0, it's 0. At 90, it's 1. At 180, it's 0. At 270, it's -1. And at 360, it's 0 again. So there you go. Just put this all together and make a nice and smooth quadratic curve. Sorry, not quadratic. I don't know why I said quadratic. Trigonometric curve. Yes, I will be streaming for AdMath students as well. Let me know what topic you want me to stream. I think I'll probably start with permutations and combinations, but yeah, we'll see about that. Okay, now, describe fully the symmetry of the graph y equals to sine x for 0 to 360. Anyone who would like to have a go at this one? Tell me what the answer is. Describe the symmetry of this graph. Okay, we're not talking this. There will be no lines of symmetry if you think about it. No. Y equals to 0 is not the line of symmetry. Because if that was the case, if y equals to 0 was to be your line of symmetry, then the shape would have been such that you would have had a reflection of this part over here and a reflection of this part over here. But that's not the case, okay? Instead, think about rotational symmetry. So this curve has rotational symmetry. So rotational symmetry of order 2. And what about the center? The center would be 180, 0. Here's your center right here. This is the center. If you take this as your center and if you rotate it, then what happens is that this part comes here and this part goes here in 180-degree rotation, and then if you rotate it another half, you will have the same curve all over again. So that means it has rotational symmetry of order 2 and the center is 180, 0. Okay, then you have a trigonometric equation. We'll look into that later, but first let's complete the past paper questions. Past paper questions that are dealing with graphs only. Okay, now here we have a curve which is y equals to tan x. Now, like I said initially, that if you do enough questions, you will have these values memorized and you won't have to do it all over again. But since we haven't done enough questions yet, it's a good idea to make a table. And this table part, you can do it in your calculator as well, by the way. I think I've made a video on it as well. I'm not too sure. I think I have. I'm not too sure. Anyway, I think this should be enough. Let's see. So here's x, here's y, 0, 45, 90, 135, 180, 225, 270. Nope, we are one box short. So here is 360. Okay, now let's start plugging in values. At 0, you will have 0, at 45, 1, at 90, infinity, at 135, -1, and at 180, you will have 0 again. Then at 225, you will have 1, at 270, you will have, wait a minute, yeah, at 270, you will have, I think I missed something. 225, 270, 315, and 360. Okay, 315 and 360. Yeah. How come nobody pointed that out? Okay. Now, at 270, you will have infinity again, at 315, -1, and at 360, 0 again. Okay, so 0, 0, 45 will be in between 0 and 90. So at 45, it's 1, and at 90, it goes up to infinity. Okay, so this is what the shape will be. And then from at 135, it's going to be -1, and at 180, it's going to be 0. So this is what it's going to be like. And then from this point onwards, it's just going to be a repeat of what we had earlier. So there you go. And at 315, it's going to be -1. At 360, it's going to be 0. There you go. That's it. Okay, then we will solve this equation later. And okay, now one more question of graphs that we have over here. Now, can you find out the equation of this graph? Can you tell me what the equation of this graph is going to be? Mahad, for AdMath student, this is barely scratching the surface. This is like very, very basic stuff if you're an AdMath student. So you can watch it if your basics are extremely weak, but this will not be enough. Walaikum salam. That is correct. Y equals to 2 sine x. Now, why is this not y equals to sine x? Because if it had been y equals to sine x, then the maximum value would have been 1 and the minimum value would have been -1. But since all the values are technically multiplied by 2, so that means this is not y equals to sine x. In fact, it's y equals to 2 sine x. But instead of y, we have f of x, so it's f of x equals to 2 sine x. That's your answer. Okay, now, so as far as curves are concerned, sketching is concerned, that's that. Now, let's have a look at some of the equations that we need to know how to solve, some trigonometric equations, and then we'll do some past paper questions as well. So here we have trigonometric equations. Okay, now, so if let's say you have y is equals to, sorry, not y equals to, let's say you have sine x equals to 0.5, okay? Now there's one thing that I want you guys to remember, and that is which trigonometric ratio is positive and which one's negative. So here is 0, 90, 180, 270, and 360, okay? Now if you think about it, let's take sine x. Sorry about that. Let's take sine x. Now, sine x is positive from 0 to 90. Okay. So here's what I want you guys to focus on. From 0 to 90, yes, add sugar to coffee. Yes. From 0 to 90, you can see that sine x is actually positive. Here it is. I'm highlighting this part for you. Okay. And from 0 to 90, you will notice cos x is also positive. And from 0 to 90, you will notice that tan x is also positive. So that means in the first quadrant, and why do we need these quadrants? How exactly are we going to use them? I'll explain this later. All trigonometric functions, that is your sine, cos, and tan, they're all positive. They're all positive. Okay. Now let's see which trigonometric function is positive in between 90 to 180. Okay. So in between 90 to 180, if you go back, you will notice that it's only sine that is positive from 90 to 180. Okay. If you look at cos, you'll notice that's negative. If you look at tan from 90 to 180, since it's below the x-axis, that means that is also negative. So that means in the second quadrant, it's only sine that's positive. Just like that, in the third quadrant, again, let me highlight this for you guys. Let me do this in red. In the third quadrant, if you focus, third quadrant means 180 to 270. Sine is negative, 180 to 270. Tan is positive. Why? Because it is above the x-axis. So that means in the third quadrant, we have tan, which is positive. And then in the fourth quadrant, if you look at cos, you will realize that in the fourth quadrant, here it is, it's cos that is positive. Okay. So that means in the fourth quadrant, we have cos that's positive. Okay. Now, a simple way to remember this is, there are two ways actually. One is add sugar to coffee, and the other is all science teachers are crazy. Mahad, I usually post on my Instagram probably like a day or two before. Okay, and I post on YouTube as well. Okay, I post on YouTube as well on the community post. Okay. All right. Now the thing is, how do we solve this question? How do we solve this equation? Okay. Now there are some steps that we need to follow, and the steps are simple. The steps are, the first step is that we find something called alpha. So here's the first step. Pay close attention. First step is find alpha. And how do you find alpha? And this alpha, by the way, is called basic angle as well. Okay, alpha, which is called the basic angle, by taking the inverse of the positive value. So here, since sine x is already equal to positive 0.5, so we don't have to turn it positive ourselves. We'll just find sine inverse of 0.5 and that's it. Now when you do that, you will have this. Sine inverse of 0.5 is equals to 30 degrees. Okay. Then comes step 2. Step 2 is that you mark the basic angle in the appropriate quadrants. Now you don't have to write all this down. This might seem a little lengthy right now because we're doing it step by step, but yeah, this is what you have to do. So if I do that, if I mark alpha in the appropriate quadrants, now notice that it's positive. Okay, sine x is what? Sine x is positive. So where is that likely to happen from 0 to 360? What are the two quadrants where sine x is positive? Sine x is positive in the first and the second quadrant. So that means when we're marking alpha, we will draw alpha in the first and the second quadrant only. Again, how do we remember that? We remember that through this. Add sugar to coffee. Let me write down the values here. Okay. There you go. Now, since alpha is 30 degrees here and alpha is 30 degrees here, that's that. Then comes step 3, the final step, which is that you find x or theta, whatever it is that's given in the equation. Here it's x in an anti-clockwise direction. So what does that mean? Let me explain. So you start from 0, you keep on moving in an anti-clockwise direction till you reach alpha. Now what is this angle going to be? This angle is going to be the same as alpha, which is 30 degrees. Then again, you start from here, you keep on going in an anti-clockwise direction till you reach the second quadrant, till you reach the basic angle in the second quadrant. Now what is this angle going to be if you think about it? If let's say we had gone all the way, it would have been 180. Now we need to come 30 degrees back, so that means 180 minus 30, which is equal to 150 degrees. So the two values that we have are 30 degrees and 150 degrees. Now at this point, it might seem a little lengthy, okay? But this is how you do it. We'll do some practice questions so that you guys can, so that you guys know exactly how to solve questions like these. Next AS Math stream, inshallah, tomorrow. No, not tomorrow actually. Tomorrow is Wednesday, Thursday. Thursday I'm streaming coordinate geometry, some difficult past paper questions of coordinate geometry. Okay, now let's do another example question and then we'll do some past paper questions. So let's say you have cos x minus 1 is equals to, let's say, minus 2. Okay. Now, first thing you need to do is you need to make sure that it's written nicely. Okay. Now, what do I mean by that? That means you have a trigonometric function. And then after that, you have, in fact, wait a minute. Let's not call it, let me make it slightly more complicated. Let's say it's 2 cos x plus 1. Okay, that's better. Equals to 0, and x is from 0 to 360. Okay. Now, before you attempt to solve any question, make sure that it's written in a way that you have a trigonometric function, okay, and then it's equal to some constant. Okay. So, which it's not, and at the moment it's not written like that. So that means we need to make cos x the subject. And when you do that, this is what happens. Cos x equals to minus 1 upon 2. Okay. Now that everything's sorted, we will calculate the basic angle. How? So here is step 1 by taking the cos inverse. And when we're taking inverse, we will not take it with the minus sign. So if you take cos inverse of 1 upon 2, you get 60 degrees. So that means alpha is 60 degrees. So that's step 1. Step 2 is that you mark this alpha in the appropriate quadrant. And what two quadrants will this be in? This will be, here's add sugar to coffee. So this will be in the second and the third quadrant. Okay. So here we have alpha, which is 60 degrees, and here also we have alpha, which is 60 degrees. Why second and third? Because it's negative. So that means it's going to be in the quadrant of sine and tan. Okay, now I like to think of them as home ground. So this is like the home ground of all trigonometric functions. This is the home ground of sine, this is the home ground of tan, and this is the home ground of cos. Okay, so cos is negative. That means it's either in the home ground of sine or the home ground of tan. Okay, now next thing you do is you find out x or theta by simply going in an anti-clockwise direction. So do keep in mind that this is 0, 90, 180, 270, and 360. So what will it be in the second quadrant? In the second quadrant, it's going to be 180 minus 60, 180 minus 60, and in the third quadrant, it's going to be 180 plus 60. So that means it's going to be 120 degrees and it's going to be 240 degrees. And there you go. That's it. That's your answer. Okay, now let's do some questions that we skipped earlier. So like for example, this question. Let's solve this. It's a 3-mark question. So first thing we're going to do is we're going to write it nicely, which means sine x is equals to 2 plus 1, which is 3, which means sine x is equals to 3 upon 4. Muntasir, inshallah, AS stream on Wednesday. I am streaming coordinate geometry. Okay? So don't worry about it. All right. Then we find out the basic angle. How? By taking sine inverse of 3 upon 4. Okay, so let's do that. Let's take the sine inverse of 3 upon 4. So the basic angle is equals to 48.59, which means 48.6 degrees. Okay? Now, so then we mark the appropriate quadrants. So since it's positive, notice that it's positive over here. That means it's going to be in the first and the second quadrant. So let's mark that. Here we have 48.6 and here also we have 48.6. So here's 48.6 and here is 48.6 as well. Walaikum salam. Now, the value of x in the first quadrant is going to be the same as alpha, which is 48.6, and the value of x in the second quadrant is going to be 180 minus 48.6. So let's do that. 180 minus 48.6. So that's equal to 131.4 degrees. And there you go. That's it. This is how you will solve pretty much any trigonometric equation. Now I'd like you guys to do part B. I'll give you guys a couple of minutes. Do part B and tell me what your answer is. $30,210. All right, let me check. So first things first, there's nothing we need to arrange. It's already tan x equals to a positive value. So we'll find alpha by taking the inverse, tan inverse of 1 upon under root 3. Make sure you use your calculator for this. Tan inverse of 1 divided by under root 3. So we have 30. Now because it's positive, that means it could be in the first quadrant or it could be in the third quadrant. Okay, so something like this. So A, S, D, C. So here's 30 and here is 30 as well. Okay, now we start finding out the value of x, which is 30 degrees in the first quadrant, and then in the third quadrant it's going to be 180 plus 30, which means it's going to be 30 and 210. There you go. My name is Saad. It's Mathlete by Saad. So okay, let me give you guys this question. Solve this question. Ahmad, we're doing trigonometric equations, trigonometric graphs and equations. Okay, let's see. So first things first, we will take the inverse of 11.43 to get the basic angle, which is, let's see, tan inverse of 11.43. So it's 84.999, so we'll have to lock it at 85.0 degrees. Okay, we have no other option but to do that. Now, because it's positive, that means it could be in the first or it could be in the third quadrant, very similar to the previous question. Okay, so that means it could be 85 degrees over here or 85.0 here. So one value of x would be 85.0 and the other value of x would be 180 plus 85, which is equal to 265. And yep, that is correct. Good job. Okay, so let's do one last question and then let's call it a day. Yeah, let's do this one. Part B. Just do part B and that should be it. Thank you, Abdullah. I appreciate it. Yes, Hamza. Let's hear it. Okay, 11.3 and 191.0. Okay. Let's see if that's true. So first things first, we will write this nicely, which means tan x equals to 1 upon 5. And then we will find the basic angle, for which we will take the tan inverse of 1 upon 5. So if you take the tan inverse of 1 divided by 5, which is 11.3, and yeah, there you go. Since it's positive, that means it's going to be in the first and the third quadrant. So the first and the third, there you go. 11.3 here and 11.3. So 11.3 for the first one, and then for the second one, it's going to be 191.3. Make sure to round this off correct to one decimal place. Okay, so that's that. Abdullah, I am from Pakistan. So I will encourage you guys to solve the remaining questions, okay? The questions that I haven't solved yet, okay? And yeah, I will stop here. See you guys inshallah in the next stream. Next stream will most likely be either of mensuration or everyday math. I think mensuration most likely, okay? So we'll do some past paper questions of mensuration. So that's it. That's it for today's live stream. See you guys inshallah in the next one.